The first thing that we like to talk to folks about when they're selecting their column hardware, the real kind of core starting point is volume. We have a volume of resin, and that volume of resin has to capture a certain volume of our sample. Different resins capture different volumes of samples. So we suggest strongly that the real core starting point would be, once you understand what you're trying to collect and how much of it, and you are maybe able to select the finalist in whatever particular resin family you want to consider, talk to that resin supplier and explain to them, this is what I'm trying to capture, how much of it, and then they can steer you in the direction of volume. And volume is it's a value of how much of the resin that you're going to end up with in the column. Now, one of the things that we do look at is aspect ratio. And aspect ratio in your column is the ratio of the diameter to the length. So for any particular given volume, we can have a tall, skinny column. We can have a short, fat column. The short, fat column will allow the sample to generally travel faster through the resin bed that we've packed. And that sounds really great because it's going to slow down the residence time in the column. But by the same token, if we're doing size exclusion type of application, it's extremely important that the sample has an appropriate amount of resonance time to interact with the chromatography resin as it's traveling through. So there is no hard, short answer to, do I need a short, fat column or a tall, skinny column? Again, the recommended starting point is to talk to your resin supplier and understand for your given volume of capture, what is the best configuration of the column that we want to look at. Columns come in many diameters and many lengths, and so we want to take a look at that aspect ratio to understand which way we're heading with that. The other thing that is important to consider when we're looking at aspect ratio is flow distribution. So if we have decided that we want a short, fat column, we typically have an inlet connection that's at the top center of the diameter. And if we don't have good flow distribution in that particular column, we're not going to get good chromatography because the sample and the flow is going to want to impact through the center of the bed and not react with the full diametrical availability of resin that's there to do the work for us. So when we are considering shorter, larger columns, the idea that our flow distribution is an extremely important aspect to the design of the column that we're going to choose. So when you're talking to your potential column vendor and you have a large diameter column and a relatively short bed height, spend some time and talk to them about the flow dynamics of the column. Explain how the flow goes in, how the flow is distributed across the bed, how the flow is collected at the opposite end of the column and accumulated, and it ejects from the bottom of the column. Conversely, if we have a tall, skinny column, then we have wall effect issues to deal with that come into play in the interaction of the flow dynamics through the column. So I gave a little chart off to the right here. It's more towards gaseous flow, but there are drag coefficients that come into play in a column that has a lot of wall area that could impede or affect the flow of the chromatography and your sample down through the center of the column.